Okay, two more sections in chapter 6. That's what we're going to be focusing on this week up into May 15th. So 6.4 we're kind of going to skip over. It's more of like an in-class type of activity, so that doesn't really work in this scenario. So we'll move on to 6.5. So we're going to talk about the sine curve, which we did in 6.3, and transformation. So the good news is transformations of the sine curve work exactly same way they did for parabolas. Inside the wacko-bracko is right-left movement. The number after the equation that comes at the end is the up and down movement. Okay, so we're going to start with that today. They just use C and D just to differentiate from the quadratic equations that we did. Okay, so let's go back to the original idea of the sine curve. So the sine curve starts at 0, 0, goes 91, 180, 0, 270, -1, and 0, 360, or 360, 0. Okay, so that's the basic sine curve. From there, we're going to move it. Okay, so let's take a look at the first one. So what happens if I take the sine curve and I move it -3? So all that means is it's going to take the regular sine curve and move it 3 units down. Okay, so you just started down at 3 units. From there, you go 90 degrees up 1, 90 degrees back down to the equation of the axis, down to 4, and back up to the equation of the axis. So it just basically takes the whole entire sine curve and moves it down 3. So this is sine x -3. So it works the same as when we were sketching parabolas. Just take the whole thing and everything shifts down 3 units. Okay. Let's take a look at the next one. The next one is sine x -60. So you'll remember that -60 goes to the right. It's wacko-bracko. Okay, so we're going to take, I divided my grid into 3s, so 30, 60, 90. So we're just going to start at 60. So every point is going to move basically 2 squares to the right based on the scale that I'm doing. So this point's going to go 60 to the right, this point 60 to the right, this point 60 to the right, and this point 60 to the right. Okay, and when we join that curve, you'll see it's the exact same size, exact same shape. This is f at x sine x -60 degrees. Okay. So you can take the same curve and move it to the right, left, up, down, same idea. Okay, let's do this next one where we put them both together. So I'm going to have a left 45 and an up 2 at the same time. So if you were considering this the vertex, move the vertex first and then apply all the points. Okay, so 45, we're going to go halfway between 0 and 90, negative 45, halfway between 0 and 90. And then up 2. So the first point or the origin is going to be right at that spot. Okay, so basically it's taken the origin, it's moving 1.5 squares that way and 4 squares up. So it takes each subsequent point takes the exact same route. So we're going to go 1.5 over and then 4 squares up, drop the point. Okay, and you'll see this one over 1.5 up 4 goes back to the equation of the axis. Normally it'd be 270, but if we go down 45, we go 1.5 over and down, from there we go 1.5 over and up 4 squares. And then this one over 1.5 squares and up 4 back to the origin. Okay, so you'll see that it looks like that. Okay, and then you just label it. This is f at x plus 45 degrees and then plus 2. Okay, so you take that kind of origin idea, you move it around, and then the subsequent points do exactly what they're supposed to do. And you'll see that all of these are symmetrical. They're all the same size. They're all the same shape. They've just moved up, down, and around. Okay, so that's the idea for plotting, the introduction to plotting these things. Okay, let's take another example. If I give you a description of the equation, what are you supposed to do when you have a description? Okay, so if I'm translating it 30 right and up 4, you're going to start with f at x. Okay, so if it's going 30 degrees to the right, it's going to be sine x -30. That tells you 30 to the right. And then up 4 units, you're going to go plus 4 at the end. Okay, so that's what the equation is going to look like. So you can go from a description to an equation to a graph. Okay, and then there's another one here that if I have, I'm going to just draw this out from scratch. Okay, so if I have a graph, let me just go here. Let me go 90, 180, 270, and 360. Okay, so let's say I start, and let's go 1, 2, 3. So let's say I have a graph that starts here, goes here, here, this would be 450 down, and then back up at 540. Okay, and then I join it with a smooth curve. And I was asked, what's the equation of this thing? Sorry, that went off the screen. Okay, so if I was given just this and I'm asked to write the equation. Okay, so you have to notice where this has shifted. Okay, it started there at 0, 0, and where has it shifted? Well, it's shifted right 180 degrees. And then it appears to have shifted up 1 unit. Okay, so if you're writing that out in the equation, that's f at x. You're going to go sine, because it went right 180, x minus 180, and then it went up a unit is plus 1. So you can also get it if they show you the graph, how you can get it, an equation and a description from that. Okay, so start with that. Tomorrow we're going to add in another value and finish off unit 6. Tonight's work is 365, number 4, 6, and 8. And again, if you have any questions, I'll be online. Okay, have a good night, everybody, and good luck.